Okay, tonight we will be learning about growth and decay. So by the end of this lesson, you should be able to solve problems involving exponential growth and decay. So exponential growth, population increases and growth of monetary investments are examples of exponential growth. This just means that an initial amount increases at a steady rate over time. So the exponential growth formula, the general formula for this is y equals a times 1 plus r to the t power. Y represents the final amount, a represents the initial amount, the starting point, r represents the rate of change, and it's very important that it's expressed as a decimal in your formula. And then t represents the time. So let's take a look at example 1, population. The population of Johnson City in 2005 was 25,000. Since then, the population has grown at an average rate of 3.2% each year. So for A, they want us to write an equation to represent the population of Johnson City since 2005. So the rate is 3.2%. And for that to be written as a decimal, we would write it as 0.032. So the general equation is there again for you. And we are going to fill in the variables. So our initial starting point was 25,000 people, so that will be our A. And then our R was 0.032. So we'll plug that in for R. So our equation would be y equals 25,000 times 1.032 to the t power. So now for B, according to the equation, what will be the population of Johnson City in 2015? Well, in 2015, t will equal 2015 minus 2005, or 10. So we want to substitute the 10 in for t in our equation from part A. So we would get y equals 25,000 times 1.032 to the 10th power, because t equals 10. And that equals about 34,256 people. So the answer would be in 2015, the population of Johnson City will be about 34,256. So now we're going to take a look at exercise 1. The population of the United States has been increasing at an average rate of 0.91%. If the population was about then what would be the population in 2008? In 2008, what would be the population in 2012? So first, let's start with our general equation. We have y equals a times 1 plus r to the t. Well, our a is our initial rate, or our initial value. And then our r is 0.91%. So as a decimal, it would be 0.0091. And then our t for this problem would be 4, because from 2012 back to 2008, that was 4 years. So we'll plug those in for our variables. And then we'll simplify. Well, 1 plus 0.0091 is 1.0091 to the 4th power. and we'll raise that to the fourth power, and that would be 1.0368. We'll multiply those two numbers together and we will get so that would be our population in 2012. Now we're going to take a look at compound growth. So the general equation for compound growth would be A equals P times 1 plus R over N to the NT power. Our A represents the final amount. Our P is going to represent the initial amount, the starting point, and our R represents the rate of change expressed as a decimal. Again, make sure to express it as a decimal. And our N represents the number of times that interest is compounded each year. And then T represents the time in years again. So let's take a look at example 2. The Garcias have $12,000 in their saving account. The bank pays 3.5% interest rate on a savings account compounded monthly. Find the balance in 3 years. Well, the rate of 3.5% can be written as 0.035, and then the special equation for the compound interest is right here. And A will represent the balance, P again is the initial amount, R is the annual rate expressed as a decimal, and N represents the number of times the interest is compounded each year. Well, since it's compounded monthly, your N is going to equal 12 for this problem. And then T will represent the number of years. So let's plug this into the equation. We would have 12,000 times 1 plus 0.035 divided by 12 raised to the 3 times 12 power. When we simplify that down, we get $13,326.49. So in 3 years, the balance of the account will be $13,326.49. So let's take a look at exercise 2. We want to determine the value of an investment of $100,000 if it was invested at an interest rate of 5.2% and compounded quarterly for 12 years. So let's just start with our equation. A would equal P times 1 plus R over N times N to the T. Well, our P will be our initial $100,000, and our R would be our 0.5% as a decimal, so 0.052. Our N would be how many times it's compounded each year. Well, since it's quarterly, it would be 4 times a year. And then our T is 12 because it's asking in 12 years. So we'll plug these into our equation and then simplify. Well, 4 times 12 is 48, so it's really to the 48th power. And 1 plus 0.052 over 4 to the 48th power is 1.85889. We'll multiply those two together and we'll get So in 12 years, the investment would be worth $185,000, $185,888.88. Now we're going to flip to the back page and we're going to talk about exponential growth. So the general equation for exponential growth is y equals a times 1 minus r to the t power. Again, your y will represent the final amount, your a will represent the initial amount, your r represents the rate of decay expressed as a decimal, and then your t represents time again. So let's take a look at this example. The original price of a tractor was $45,000. The value of the tractor decreases at a steady rate of 12% per year. So they want us to write an equation to represent the value of the tractor since it was purchased. Well, the rate of 12% can be written as 0.12. And then the initial amount was $45,000, so we'll plug that in for A. The 0.12 will go in for R. And then simplifying that, our equation to represent the depreciation would be y equals 45,000 times 0.8 to the t power. For part B, they want us to find what is the value of the tractor in 5 years. Well, we'll just take that equation from part A and plug in 5 for t. And when we simplify that down, we get $23,747.94 for the value of the tractor in 5 years. Right. So let's take a look at exercise 1. The population in Bulgaria has been decreasing at an annual rate of 0.89%. If the population was about then the population was about that in the year 2005. Predict the population in 2015. Well, let's start with our equation. We have y equals a times 1 minus r to the t. Well, our a will be our initial, so our starting population. Our r would be our 0.89% in a decimal, so 0.0089. And our t would be 10, because from 2005 to 2015, that's 10 years. So we'll take it and plug it into our general equation. And we will simplify from there. So 1 minus 0.0089 to the 10th power is 0.91448. We will multiply those together. So that would be our population in 2015. Go ahead and take a look at number 2 and try that problem, and we will discuss it tomorrow. Have a good night, everyone.